Yeah. Good morning, everyone. I am very happy that today among us, Dr. Avtar Singh is present as our external expert. Before starting this proceeding, I would like to say something about the DAXA. Avtar Singh is a scientist, senior scientist in ICAR CSRI Karnal Institute, Karnal, India. He is also taking PG classes there from 2023. He holds a PhD in soil science from Banaras Hindu University, BHU. He bagged ICAR, JRF, SRF scholarship during his MSc and PhD degree. Broadly, his work involved reclamation of management of salt-affected soils and water for halting and degradation and improving crop productivity in Northwest India. Additionally, he also worked on application of biochar for managing soil health. He is also associated with the international collaborative research project with Netherlands and Japan. Raksha has been the author of 20 research articles, including several books, chapter in similar field, and he also received several high impact factor journals. Many more is to say about Raksha, but due to the time constraint, I will be stopping myself here. I would like to introduce my panelist also, Dr. Wadrik, Assistant Professor, Dr. Nitin Madan, Associate Professor and Head of Department, myself, Dr. Harmohan Singh, Associate Professor. So again, I welcome you, Doctor. Thank you for being with us here. So permit me to start the proceeding.
Okay.
Thank you.
Thank you, sir.
Let us start.
Okay. Good morning, everyone. Good morning, respected sirs. So I will start my final thesis submission presentation with the start of my topic. The study, the name of the topic is the study of different agricultural practices on soil quality and organic carbon pools or MAIZE in semi-arid region of India. This was done under the supervision of Dr. Nitin Madan Sanghade sir and co-supervised by Dr. Thomas Maite sir. So at the start of the introduction, we can say that the food production in India has magnified since the 1960s due to the Green Revolution, and the use of these high-yielding variety seeds and inorganic fertilizers has intensified agriculture, but this has incessantly deteriorated the soil health because and this green revolution it is necessary since the projected rise of the population is at 9.8 billion by 2050. So in order to secure a good soil health and secure good soil quality, we need to increase the amount of soil organic carbon in the soil. So the occurrence of organic carbon, this is a key indication for the quality and as well as the productivity of the soil. The soil organic carbon content, this improves the soil, the cropland fertility and agricultural sustainability. And focusing on maintaining the soil organic carbon levels at an optimum level could provide a positive impact in the long run. So, considering this soil health sustainability and climate change scenario mitigation, apprehension of carbon is very. Just go to objective. Okay. Considering the sustainability and quality of the soil, we have come upon 5 research objectives. The first objective is the evaluation of different agricultural practices on soil health attributes and development of soil quality index. Second is to study the variation of different pools of soil organic carbon under different agricultural practices. The third is to study the influence of different agricultural practices on the livability index of SOC. The fourth is to investigate the microbial population in soil under different agricultural practices. And the fifth is to study the effect of different agricultural practices on the yield of maize. I have come upon some review of literature. I have collected some review of literature regarding this also. Coming to the materials and methodology, this was a study area. It was done in the experimental field of Department of Soil Science, W Professional University, Punjab. And this was done for 2 seasons, that is Kharif of 2022-23 and Kharif of 23-24. This is the climate record of the experimental period. Coming to the details of the layout, it was done in randomized block design with 10 treatments, 3 replications, the number of plots totaling 30. The net plot size is 15 meters square, that is 5 meter into 3 meter. Net cultivated area is 450 meters square. This is the experimental field layout. And coming to the experimental details that we had provided, there were a total of 10 treatments. The first is T1 is fallow, next is straw mulching, plastic mulching, minimum tillage, earthing up, PFO, broadcasting, ridge and furrow, no weeding and weeding with weedicide. Earthing up is the process where we collect the soil, and this is like जो हम क्या करते हैं हमारे क्रॉप की एरिया पे जो अर्थिंग अप करते हैं सर इसको हाँ लाइन बना देते हैं सर. Next, okay. So coming upon the different organic carbon pools. The organic carbon pools is divided into 4 major types: the CFRAC 1, CFRAC 2, CFRAC 3, and CFRAC 4. The CFRAC 1 is very labile in nature. CFRAC 2 is labile in nature. CFRAC 3 is less labile, and CFRAC 4, this is the recalcitrant organic carbon pools. The soil organic carbon stocks, this was calculated using the formula given by SEMI-ARID. The livability index was also calculated by the formula given by Hazra et al. The initial readings of our soil sample are given in the presentation. We estimated the soil texture, pH, EC, bulk density. This is an available NPK, available S, exchangeable CAMG, soil organic carbon, the 4 different fractions of carbon, total organic carbon, soil organic carbon stocks, livability index, soil microbial biomass carbon, the dehydrogenous activity, the bacterial count, and as well as the fungal count. So this is the process or the steps that was required to develop the soil quality index. For the development of the soil quality index, some major steps were followed. The first is the selection of indicators and generation of minimum data set. The second is scoring of all these values and transforming them into 0 to 1 scale. The third is the assigning of weight to different indicators, and the fourth is assembling the indicators into soil quality index and testing the significance across different. MDS is minimum data set. Because we had taken all like 25 data sets, we need to estimate only few of the data sets so that these are more like functioning indicators qualitatively as well as yes. The scoring values and transforming them into 0 to 1 scale, this will provide, if the soil parameters will transform into a unitless scale, that is 0 to 1 scale, and by using these 3 types of standardized scoring functions, there is the more, if more is better, if less is better, or if optimum is better. After assigning this individual variable in the minimum data set, it was allocated a weight. and it was intended as a ratio between indicator factor loading and cumulative component load. This will be used, after all of this, the soil quality index will be calculated with the given formula. So this is coming to the results and discussions. These are for the soil textural classification. We had estimated the sand clay particles at 0 to 15 cm, two soil depths, that is 0 to 15 centimeter and 15 to 30 centimeter. There were no significant changes in the soil textural classification. And upon estimation with the textural triangle, the soil in the surface as well as subsurface soil was classified to be sandy loam texture. This is the data for the pH. There, in the fellow, there we can see there are no significant changes in T1. We can see a slight decline, but there were no significant changes in the pH. This slight decline in some of these treatments, this could be due to the organic mulching, decomposition of the organic materials. This is the pH for the soil depth 15 to 30 centimeter. Yeah, in every case, in T2 there is a strong mulching treatment, sir. There was slight decline. There was some slight decline. This could be indicated, which could be due to, I have written it over here. This soil buffering function pH this is one of the most important reaction in the ecosystem. During the experimental period, the horizontal distribution data from 45 days to 450 days after sowing were observed. A slight decrease was observed in T1, T2, T5, T6, T7, T9, T8, and T10. Incidentally, the pH in subsurface soil layers observed a slight decrease in treatment T1, T2, and T7. This pH, this slight decrease in the soil pH, this could be due to the application of organic mulching. These organic acids, which were released during the decomposition of these organic residues, could cause a decline in the soil pH. Okay.
First trial और second trial के कुछ में वो land फैल होता है
उसमें फेल होता सर
मतलब
फर्स्ट ट्रायल के 2 ईयर का है
फर्स्ट में जाके उसके बाद फैल
हाँ एक सीजन खत्म हो गया फेल हो फिर नेक्स्ट सीजन में So after this is the data for the EC. Also there were no significant changes, but we can see that the values of pH, this shows less variability during the entire experimental period. The surface soil in treatment T1, T2, T5, T6, T8, and T9 observed a slight decreasing gradient. The remaining treatment T3, T4, T7, and T10, this showed a slight increase. The inorganic fertilization induces an increase in electrical conductivity on wheat maize cropping in the endogenetic plains. This was given by Chaudhary et al. And Sandev et al. Nonetheless, the application of vermicompost could integrate a potent effect on soil EC. The application of 10 tons per hectare of vermicompost, this resulted in a decrease in electrical conductivity. As for the bulk density, there were no significant changes. Coming to available nitrogen, in each of the treatments, we had provided the RDF as well as the 10 tons per hectare of vermicompost. Due to this, we can see that there is a slight increase in all of the available nitrogen across the treatments. The major increase was found in treatment T2, that is from 108 at 45 days to 154 kg per hectare at 450 days. Similarly, this was at 15 to 30 centimeter. This gradual increase in available amount of available nitrogen, this was noticed when the experiment progressed from the first trial to non-growing period to in both soil layers. The fallow treatment, that is T1, did not exhibit much changes, significant changes. As an increase in the available nitrogen was seen in the initial stages of second trial, which could be due to the application of nitrogen. So the application of nitrogen in organic fertilizer and vermicompost could have provided an increase in the available nitrogen. Coming to the available phosphorus part, we can also see slight increases over, slight grading over coming from 45 days to 450 days. Major increases were seen in T2 and T4. This is the data for available phosphorus at 15 to 30 centimeter. The available phosphorus list observed significant variation in the treatments and across the horizontal data distribution. It could be seen that there is a gradual increase in the available phosphorus along with the increasing number of days in both surface layers, surface soil as well as subsurface soil. The addition of inorganic fertilizers accompanied by vermicompost treatment, this could have increased the available phosphorus in both soil layers. The organic mulches acquires a tendency for accumulation of available P. This is a potassium level at available potassium level at 0 to 15 centimeter and 15 to 30 centimeter. Observable effects of available K was higher during the two trial periods and lower during the non-growing period, that is the fallow period. A slight increase could be ascertained in the subsurface layer. The organic residue replication as well as retention offered by better available K in soil through the decomposition of highly K-loaded biomass. And a study by Thomas et al. 2007 indicated that there is increased accumulation of available K within the tillage system in the subsurface layers, which is more than the subsurface layers. This is the data for available sulfur. We could also ascertain a slight increase, but there were no significant changes. The available sulfur is specified. This is specified in relation to the increasing number of days. The available sulfur at both soil depths, this developed a slight increase during the trial periods. According to Sharma et al., different tillage practices could significantly influence the accessibility of available S. We could also see there were some slight increase in the extensible CA and MZ. Coming to the soil organic carbon part, this is one of the most important factors, this is one of the most important functions to evaluate the soil quality. So we can see from the data that in all of the treatments going from the first trial to the non-growing period to the second trial, there is an increase in the soil organic carbon. The major increases were seen in straw mulching T2, that is from 4.93 to 6.87. The next is in the minimum tillage, that is from 3.80 to 6.67. So with the application of 10 tons of vermicompost as one of the major treatments, like this could have induced an increase in the soil organic carbon, as well as the different agricultural practices that were employed over here. Similarly, we could ascertain some increase in the soil organic carbon content in the subsurface soil layers. This different agricultural practice. This is subsurface soil layers, sir. This is from 15 to 30 centimeter. Two depths, sir. Yes, 0 to 15. No, sir. Okay, so we only took two soil depths, sir. There is 0 to 15 centimeter and 15.
Sir, means yes.
Fibrous root system, fibrous root system होता है, so it's okay. Sir, this is an indication that this is depth 1, depth 2, and depth 3. D1A is the D1A indicates the 45 days after sowing at depth 1. That is 0 to 15 centimeter.
Okay.
This D2 will describe the subsurface soil layer.
Depth 2.
Depth 2. And A will indicate the 45 days.
B indicate 90 days.
Yes, B will indicate the 90 days.
So, D2, yeah. B is 90 days.
D will indicate.
Sir, the A, B, C, D for the different days, and the D2 is 52 days.
D for depth, and
these are for the days.
A, B, C, D, E for the days.
Okay, thank you, sir. So, this is a discussion for the soil organic carbon content. The different agricultural practices, this introduce significant effects on the functioning of soil, including the soil biogeochemical exchanges. The plastic mulching treatment may reduce the soil organic carbon content through increased mineralization in organic matter and increased microbial activity. And then some other contrasting studies also confirm that plastic mulch might increase SOC, which could be due to the increased probable biomass and later return in the soil. This was seen in our case such that at first time you can see a slight decrease in the SOC at plastic mulching, and this was increased later on. This could be the reason for that. The increased biomass in the root system could have managed to develop alteration in the soil physical, chemical, and biological properties. This would explain the initial decline in SOC and later develop increase in the surface layers in the non-growing period. The reduced soil disturbance as well as reduction in soil temperature as well as increased biomass, this could have led to certain interactions and increased SOC in minimum tillage. So, the majorly the thing is the deposition of this root biomass from the cropping system and decomposition over time could increase soil organic carbon in the lower soil depths. So this is an interpolation data for the soil organic carbon across different days after sowing. This is the first being at 45 days, 90 days. We can see a increase going from the left side to the right side, to the right bottom. This is the data for the total organic carbon. Major increases were seen in T2, that is straw mulching, from 6.80 to 12.60, that is in gram per kg, and at minimum tillage, that is from 5.20 to 12.67. Data for total organic carbon at 15 to 30 centimeter. The total organic carbon, this is an inclusive parameter for the oxidizable carbons and other related soil organic carbon fractions. From this experiment, it was observed that there is an increase in the total organic carbon at the different agricultural practices, and the integration of this 100, that is the RDF, along with the organic amendments, that is the vermicompost. This seems to magnify the total organic carbon content in the soil. The biomass accumulation was more in the surface layer rather than in the subsurface layer. Then this could be the reason that the total organic carbon was higher in the surface layer compared to the subsurface soil. This is the data for the soil organic carbon stocks. Similar with the other data, like we can see that there is an increase in the soil organic carbon stocks going from 45 days to 450 days. Major increases were seen in T4, that is minimum tillage system, going from 8.56 to 5.75 to 14.50 megagram per hectare. followed by the T2 treatment, that is stromulzine, going from 10.07 to 13.91. Inclusive data for soil organic carbon stocks at second depth, that is 15 to 30 centimeters is given. The accumulation of soil organic carbon stocks, that this is higher in the lower soil depths as compared to the upper soil depths. There was significant variation across the horizontal data distribution for soil organic carbon stocks. There seems to be an increase in the soil organic carbon stocks along the increasing number of days. The SOCS in the surface soil saw a significant variation, and the highest was observed in T4, that is the minimum delay system, followed by the stromulzine treatment. This was also emphasized by Bhattacharya et al. That conservation practices, this increases the soil organic carbon stocks mostly at the surface layers. The mixing of crop residues, stubbles, and plant roots in subsurface soil could have induced higher increase in the soil organic carbon stocks than the subsurface soil. This was also given by Piccoli et al. That higher soil organic carbon stocks were noticed in the subsurface soil of conventional tillage systems. Lability index. Lability index is an accumulation of the different this was calculated from the different carbon fractions, which was divided by the total organic carbon. This is a great indication of the soil quality. We could see certain variations in all of the treatments. The lability index, there was a decline in the lability index in T2, that is from 1.70 to 0.92. This will indicate a higher soil quality in that specified treatments. Lower the lability index, higher will be the soil quality. The lability index is an important determining factor for the soil quality and soil health. This lower the lability index, the better will be the soil quality. The treatments T2, T3, T4, and T9, this develop lesser lability index in the subsurface layers, and the fellow treatment T1, this indicated less variation in the lability index at both soil depths. This is the interpolation data for the lability index at very across the increasing soil depths. Soil microbial biomass carbon. We could also ascertain increases or changes in the soil microbial biomass carbon. Maximum increase was seen at the stromulzine treatment, that is T2, that is from 252 to 346. At T3 it was 306 to 372 in the surface layers. In most of the cases, the SMBC seems to increase during the two trial periods, and it seems to decrease in the non-growing period. That is the fallow period. This could be due to some environmental factors such as high rainfall during the period, or there could be frosting period during that time. The SMBC, this is a measure determining parameter for the amount of carbon contained in the microbial community. The study emphasized that the microbial biomass carbon injection was high during the crop growing season, that is the trial periods, and there was less activity of microbes during the non-growing period. The maximum SMBC amongst the treatment was seen in T3, which was closely followed by T2.
Highlight on importance of semi-standard things.
Okay, sir. Sure. Yes. So similarly, as I have said, from the study of Lepsa and Devi, it was found that SMBC was highest during the rainy season. It was low, and it was lowest during in the winter months. This is the data for the dehydrogenase activity. We could also ascertain that there is an increase in the dehydrogenase activity over time. Dehydrogenase activity is closely related with soil microbial biomass carbon. So there was an increase in during the trial periods, as we can see in the data, but there was less there was a reduction in the non-growing periods. This dehydrogenase activity expresses the rinse and oxidation of organic matter by microorganisms, and it could be a good indicator of microbial activity in soil. So during the experiment, it was seen that the dehydrogenase activity was high during the progrowing periods, that is the first trial period and second trial period, but this decreased during the non-growing period. Data for the bacterial count, data for the fungal count. And this is the data for the different organic carbon fractions that we have allocated. That is the carbon fraction 1, carbon fraction 2, carbon fraction 3, and carbon fraction 4. Carbon fraction 4 being the recalcitrant pools. This is very important for estimating the soil quality as well as soil health. This was the data obtained for the different carbon treatments at carbon pools at fallow, straw mulching, plastic mulching, minimum tillage, earthing up, peer road treatment, broadcasting, ridge and furrow treatment, no weeding, and weeding with weedicide. The active pools are an amalgamation of the CFRAC1 plus CFRAC2. The passive pools are an amalgamation of CFRAC3 and CFRAC4. This interpolation data shows the active carbon pools as well as the passive carbon pools. So coming to the soil quality indicators, the contribution of soil quality indicators to the principal components. The principal component analysis was performed for determining the correlation between the variables, that is 25 in numbers.
How many slides do you have? How many?
130.
Still how many are left? Have you taken out a
What year? 99, sir.
99, okay. So you just emphasize only those and that's how it's telling that. Tell me the significant result only, that this, followed by this, followed by this. 3 or 4 just only.
Okay.
Right?
Yeah, I will try to
You describe how you calculate soil quality index and which parameters.
Yes, I will try to.
Important. Then we will move to the proposal.
Okay, sir. Thank you, sir.
Because we have already seen that.
So all of the previous data collections that we had done, this was done in order to quantify the this soil quality parameters. This principal component analysis was performed across all the 25 parameters, the physical parameters, biological parameters, as well as chemical parameters.
See that.
For the indication of soil quality parameters at the first harvest, the PCA analysis was done at 90 days and 42 days. 2 analyses were performed. We could see variation in soil quality in the soil qualities expressed through principal components. So the maximum factor loading was seen in SOC, CFRAC4, BD, available K, available P, sand and silt in the first harvest. So there was a selection of minimum data set. So from the 25 treatments, 7 of the data sets, these were selected for the calculation of the soil quality index in the first harvest. This is the 7 these principal components were selected for the 15 to 30 centimeters of soil depth, and this was loaded in the minimum data set, and this will be used for the for attaining the soil quality index in the first season, first harvest, and in the second half.
Carbon fraction 4 is variable.
Carbon fraction 4 is what?
Which are representing variable carbon.
No, carbon fraction 4, this will indicate the recalcitrant carbon, sir.
No, the right.
CFRAC 1, starting from carbon fraction 1, that is the very level.
Very level.
Yes, sir.
Why?
In the second season, six factors were selected for the minimum data set at 0 to 15 centimeter. 7 factors were selected for minimum data set at 15 to 30 centimeter of second harvest. This represents the correlation of between the different treatments. Higher the angle between these treatments, this will indicate a higher correlation. So, the development of the soil quality index, this is one of the most important objectives to accomplish. So in the development of soil quality index for the surface soil, the analysis of variance for the 7 data sets that were selected was indicated, and this was assigned weights. The weight of each species was calculated through percentage of variance, and this ranges from 0.149 to 0.234. The maximum factor loading was seen in SOC, and minimum was seen in cell and clay. After the analysis, it was seen that we can see that these are the weights that were assigned. From out of the 25 parameters, we had selected 7 parameters from the minimum data set. Weights were assigned according to the increased number of variability. There was maximum weight was seen in soil organic carbon. Least weight was seen in the silt at 0 to 15 centimeter. Similarly, at 15 to 30 centimeter, we see that the SOC soil organic carbon had the highest weight, and the lowest weight was seen at silt. With this, we calculated the soil quality index, which was maximum in T2, that is the straw mulching treatment, closely followed by T4, T6, and T7 in the 0 to 15 centimeter soil depth. And at 15 to 30 centimeter soil depth, the soil quality index was seen to be highest in T2. Similarly, for the soil quality index development at second harvest, a total of six indicators, sensitive indicators, were selected for the first surface soil, and a total of 7 indicators were selected at subsurface soil. This is the data for the soil quality index for the second harvest. Coming to the yield of maize, we can see that the maximum yield was seen in straw mulching at both first trial, and it seems that there seems to be an increase in the yield of maize going from the first trial to the second trial. So coming to the summary and conclusion, we can see that we classify the soil type as sandy soil, sandy loam texture in both soil surface. Certain treatments in like straw mulching treatment, this saw a slight decline in pH, while they were consistent pH in across all the treatments. Most of the treatments had a tendency for slight decline in EC. The bulk densities developed no significant changes during the trial periods and ongoing period. The available NPK showed a slight increase during the experimental period, and the soil organic carbon, this was found to be the highest in the straw mulching treatment T2. It was closely followed by this minimum TLS T4. The soil organic carbon stocks, this was highly retained in the minimum TLS system T4. After summarizing all the findings, it could be concluded that the addition of these straw mulches, this could enhance the soil functions while maintaining the fertility and productivity of crops. The biological activity of soils were also significant correlation with the T2, that is the straw mulching treatment. The soil quality index that we had just seen, this was indicated to be highest in the straw mulching treatment, which was closely followed by T6. The measure perspective of the treatment was to interrelate all of the measure objectives and determine the most suitable agricultural practice that would improve soil quality, retain the soil organic carbon and its different fractions, increase soil fertility and its productivity. On this basis, The straw mulching treatment T2, this was considered to be the best agricultural practice, and this could be recommended and adopted. So this is the publication that we had done for the from the experimental data. Patent publication. This is the certificate of participation in conferences. Book chapters were also published, and this thesis was also applied for the nomination of Best Thesis in CO2 India, RSC Best Thesis Award. These are some of the field trial photography for this is it, sir.
Thank you, Jackson, for your nice presentation.
Thank you, sir.
Now we will ask and we will discuss some suggestions as well for further improvement.
Okay, sir.
Basically, why you selected this problem, this hypothesis? What was it that time, Genesis, and how this idea is
Okay.
coming to?
Sir, in most of the cases, we have seen that all of the farmers, all of the researchers, most of them, they were mostly focused on increasing the productivity of the soil, of the crops. But we could see that there was a decline in the soil, in the soil health, as well as soil quality, because we had put all of this, we can say, inorganic fertilizers, that is nitrogen and like NPK as such, urea, we have put it. This has caused an incessant, you can say, decline in the soil structure, in the soil quality. So, as such, we have seen that increasing the soil organic carbon content in the soil, this could help mitigate this deterioration in the soil quality. So as per this, we had selected different treatments that could provide us some fluctuations in the soil quality because of this SOC. That is why we had performed this experiment, sir.
What you were expecting in the Punjab region, initially farmers is more focused on the rice.
Yes.
But almost I think in your region also more focus is given to the maize. So last year I think the sort is that is on the maize. What do you think? Maize is more important than rice? And what is the last 3-year, 4-year trend? Maize is replacing rice or still maize is behind the rice?
So as we can see, cereal crops, they are like the queen of cereals. We can see is wheat. In the Punjab region, as far as I have seen, the wheat crop is grown. We can say that wheat crop is the first, rice will be second, third will be the maize. And maize is one of the major crops that is upcoming in the Punjab region, sir.
May have potential to replace the rice in the upcoming next 2 year, 5 year.
No, it's not possible because like we can see that the staple crop that is mostly consumed by the people over in the North India. We can say this is the wheat flour. We can say.
Okay, you have a dedicated institute on maize. You know that institute in this region?
No, sir.
One of the area institute who is dedicated to research on the maize.
Okay.
You know that?
No, I haven't been.
You
sir.
should know that.
Okay, I haven't been, sir.
Because that institute is, I think, 30 to 40 kilometers from here.
It's very relevant questions are asked.
Okay, yeah, yes, sir. I visited जो हमारा पोटैटो का SES है उसमें तो मैंने विजिट किया पर I haven't visited the maize one, sir.
That is the Indian Institute of Maize Research. This is a ICAR institute.
Okay.
In the Ludhiana, Ladwa, maybe that region is Ladwa. They recently established that. That institute was initially in the Delhi, but after that transferred to Ludhiana,
okay.
only for to popularize the maize as well as the replacing rice in that region.
Okay.
But I saw and I also listened something like now the farmer is growing maize because of the purpose of silage. For the silage purposes, maize is gaining importance in this region also. Its area is increasing.
Sir, here also mainly summer season is from
Yes.
February to up to June. After this May, June, May.
Yes, most of them like.
But after that, they shift that maize rice, in the rice is having different season, and maize and they go throughout the season.
Okay.
So I think one point also that we should not think that maize should replace the rice. Actually, they should incorporate in their circle.
Yeah.
After 2-3 years, they should do the maize. Not every year.
Because maize is most important for the
If you
nation.
completely replace them, then may not be able.
Replacing is
We can do that maize, rice and wheat. This cycle we can.
replacement is not a, it is an integration. Means some area is a farmer means they have allotted at least 10%, 15% area of their cropping system to the maize.
Yeah.
For the fodder, because fodder is also the challenge for this summer season. And straw, you have applied the wheat straw.
Which straw? In straw matching, sir.
Wheat
Yes,
straw.
yes,
So
sir.
you have observed that there is any immobilization deficiency in the maize.
No, sir, like- Practically no, sir.
Decomposition is good.
Decomposition is good over here because temperature is high in Punjab region, so decomposition is good, sir.
Compared to rice straw.
No, yes,
Wheat straw, we need to do
Decomposition.
Yes.
Not a issue of the immobilization type.
no, sir, no, sir.
Nitrogen immobilization.
that. We did observe
I
that.
think because the gap is there. If you are taking final and
And also I think that's because mulching is there, not
That's it.
decompose also.
if both the things go together, then improvisation will be there.
Yes, sir.
Same right.
Mm.
The both the process, but you have
A long time,
sufficient gap there.
yes, sir.
So that's why it is not.
Just how you measure the dehydrogenase activity?
Yes, sir.
Dehydrogenase activity.
How I measure it?
How you
Okay, sir.
which methodology you use?
Okay, this is done by TPF reduction method, sir.
What is TPF?
TPF is triphenylformazan.
Okay.
Triphenylformazan reduction method was used, and the accumulated samples.
What substrate you have used to treating this soil? For you measure the TPF, but
Okay.
one is another.
TTC, the reduction from
TTC.
TTC to TPF.
What is
sir.
TTC?
Triphenyl tetrazoline chloride, sir.
Yeah. Triphenyl tetrazoline
Chloride.
chloride.
Mm.
TTC you have added.
Yes, TTC I have
Also,
added.
I think you another substance you added for the carbon source. Right?
Yes.
What is that?
There is the major source of carbon was vermicompost, sir.
No. In this method, you added TTC, and you also add, I think,
Just few minutes. That's it. Just few minutes.
calcium carbonate or glucose.
You have class.
No, I didn't anything, sir. I didn't do this, sir.
Okay. Then you have measured how you measure the TPF concern. How you extract?
TPF was extracted, and after that,
How to extract TTC?
extraction from TTC to TPF, the TTF to the sorry.
You have added TTC in the soil. Then what is the second step?
There was incubation period. Incubation period for 1 hour.
Okay, after that.
After that, filtration was done,
Okay.
and after that it was
No
measured.
filtration, which solution you use? Water?
No, nothing, sir. We just used filter paper, sir. And after that it was seen in the.
No, I think you use the methanol.
No, I didn't use methanol, sir.
Then how you extract the TPF? Because TPF is dissolved in the methanol. No, you have measured that TPF on the which instrument?
TPF, this was measured at in spectroscopic test.
So then definitely you use the methanol for the extraction of the TPF.
Okay.
You added the methanol. Then you filter the soil.
Okay. Because
Otherwise it's not possible how you filter.
okay, sir. I'm sorry because I have done this experiment 2 years, 1 year, 1 year and a half before, sir. So
Okay. And which methodology you use for the microbial biome of carbon?
nitrogen,
Microbial biome.
microbial biomass carbon, sir. That was from fumigation extracts.
Fumigation method.
Yes, yes.
Okay. And what you think if we will not going for the means what is the advantage of doing the PCA and MDS for all the soil health parameters? Why we will calculate the soil quality index?
Okay, sir. Mostly we can say that there are several determining factors. Okay, sir. The soil quality there are several soil physical parameters, chemical parameters, biological parameters are there. So if we aggregate all of this in the data set, this will be a bit complex. So certain data sets, this was acquired from the PCA, and this was incorporated in the minimum data set, and this was used in the like these are some of the most important soil functions, and this was incorporated in the attaining the soil quality index, sir.
You have mentioned all these methodology.
And I have also one other thing suggested in the thesis. That is, I think, sir is also not, I think, understand that query. I have asked you have added the this PCA equation in the result. Sir, no, actually, you have added in the test method. No, you have write that weighted score and score in the test. They write it in the test, but if they presented that this equation soil quality index, last one, weighted score and multiplied indicator score.
Okay.
You have, like you write the name of that, like the total organic carbon, and then multiply by the what is the indicator score.
Okay.
Then you plus again second, you write the second weighted parameter. Then you multiply by their weighted score. That is you represent in the equation form. What you have already you mentioned in the test. This is the indicator score for this parameter. For second parameter, this is indicator score. For third parameter, this is indicator score. But if you mention that all the indicator score in the equation form, like you have already mentioned in the methodology, in this equation I have used. You put all that values in your this equation. That is better indication and better reflection of that your calculation.
Okay. Yes, I can understand your point of view also, sir. But yes, I can understand. But the major thing is also that after calculation of this SQI, like we had also like incorporated this in. May I show you? All of the things that I did, this was incorporated.
No,
yes. Okay.
Like this equated score, you have like TOC multiplied by what is the 0.92 factor. Then you plus BD. And what is the multiplied by factor this? Plus what is the your labile carbon fraction 1. And indicator score is 0.4. Then you plus again the fourth factor. Then multiply by that indicator score. Then your equation is. Anyone seeing that equation, they know everything.
It is better synchronized.
You have right in the test. I saw that methodology. You have right all the this indicator score for this parameter, then for second parameter, this is the indicator score, third parameter, this is so that is going in the paragraph, and the very big paragraph. If you will present it the equation, then it's very nicely presented to all the findings possibility you can add.
Yes, sir.
I think it's means have already information is there only the verification of the
reason with that.
that is what I saw.
Yes, sir.
You have already mentioned.
Note Khaidem Jackson. You can forward the suggestion.
Okay, sir.
And also, sir, I have one suggestion for Jackson.
Yes, sir.
You maybe go for the calculation of the carbon footprint in your publication.
Yes, sir.
It's better. You have all the data of carbon.
Yes.
So carbon stocking is there, breeding is there, and if you will calculate that carbon footprint, how much carbon emission you use for which practice,
Yes, sir.
then it will
Yes,
be very good for your publication. That is called carbon credit or carbon footprint. Really now these things are going on.
Yes,
So
sir.
it's a good publication for practice. If you will you like only you need some emission factors which is already published in the many several
Yes, sir, yes, sir.
several items. You only take that factor and you multiply with your so what is the amendment you for which parameter, how is carbon emission? There is a paper law.
Yes, I have seen, sir. I have seen, sir.
They giving the many factors. Things like in the last treatment you have mentioned the VD side management by VD side. VD by VD side.
Yes,
So that is there is the emission factor for the VD side. How much VD side you plus then your carbon emission is increased. So likewise you calculate the plus minus. Means
Yes,
there is a carbon capturing and carbon emission.
Okay,
Which your practice. That is will be a very good publication.
Yes, sir.
So you will try.
Yeah, I will try, sir. I will do
Publish
it.
with the help of sir and your team.
Yes, sir.
It will be nice for you. Okay.
Thank you, sir.
So you can ask the
Classes come up.
Okay.
Thank you very much for your valuable suggestions. If
Question also from your side. We have the group and
Okay.
okay, so thank you, Jackson, for the presentation.
Thank you, sir.
I will give you special thanks to Dr. Avatar Singh. Thank you, Dr. for your valuable suggestions so that the claims will be much valuable in useful. I hope that you will incorporate the suggestion. Dr. Rafiq, anything from your side? It's okay, huh? Okay. So, thank you. Yes, sir. Anything you want to say?
No, it's best wishes from my side. Your thesis is really very good, data is really very good.
Thank you,
but
sir.
now you have to again synthesize.
Yes, sir, yes, surely.
Suggested. And for publish more relevant, I think you have already applied one patent.
Yes, sir, yes,
From this that is also very good.
Yes, sir.
Maybe I can provide you. Kindly communication. Finally, congratulations from my side.
Thank you so much,
for
sir.
the award of the degree.
Thank you, sir.
And like the best wishes
Thank you,
for
sir.
your future journey.
Thank you.
And I hope you will publish at least 2-3 impact factors on this
Yes, sir.
wonderful thesis.
Yes, sir.
But you and your advisor did a lot of work.
Yes, sir.
Also highly appreciated statistical design tools you have used for your thesis. So again, thank you.
Yes, sir.
Congratulations.
Thank you so much, sir.
PhD award.
Thank you so much. Thank you, everyone.
Credit goes to that co-supervisor. Dr. Thomas, he is very much expert in that statistics.
Okay, then
No, sir, sir has also helped a lot. Sir is there for me all the time. So he has helped me a lot along the way. So I thank you, sir, for that, sir.
Thank you, sir. Thank you for your best.